All right, so let's try number 3. So number 3, we have a couple binomials, right? So anyway, first thing is we set one side equal to 0, right? So I need to get this 64 over to the other side. And so we get x squared minus 64 equals 0. So here's a situation where b equals 0, right? Like this is the constant term, that's c. We have the quadratic term, of course, but what we're missing is the linear term with the x, right? So that means b equals 0, okay? And so a equals 1 and c equals negative 64, right? So let's plug this into our formula. So x equals negative b plus or minus the square root of b squared minus 4ac, right? All over 2a. And so I'm going to plug in b, which is 0. Plug that in here and here. Then a is 1, so I plug that in here and here. And c is negative 64, so we plug that in here. All right. So these zeros go away. All right, we can ignore them. So down here, I'm just going to get plus or minus, and let's see what comes out of this radical here. So, so b is 0, but I still have to evaluate this, right? So I have negative 4 times 1 is negative 4. Negative 4 times negative 64 is going to be positive 256. Okay, and so the square root of 256 is 16. So once again, we get a positive, and it's a perfect square, so we put 16 right here. And then on the bottom, 2 times 1 is 2. So we get plus or minus 16 over 2, which is plus or minus 8, right? And you can leave that as your answer, or you can write 8 comma negative 8. Either way, okay? Either way is fine with me. But just remember that this means 2 answers, right? If you have plus or minus 8. All right, so that's what happens when b is equal to 0. You're going to get 2 numbers that are opposites. Okay, so when b is equal to 0, you get 2 numbers that are opposites. And that's how it always works out, because you don't have that thing to add or subtract in the front. So you just end up with plus or minus one number. All right, number 4. Now we have the side set to 0 here. And when we identify a, b, and c, this time c equals 0, right? So we have a is 3, b is negative 2, and c is 0. So let's see how that plays out. So I'm going to say x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to put in negative 2 for b. I'm going to put in 3 for a here and here, and then 0 for c. So that 0 is going to cancel out that whole value, right? Here I have a negative negative that turns to a positive, so I end up with positive 2 plus or minus. And then when I do what's under the radical, I'm just going to get b squared, right? So negative 2 squared is positive 4. When I take the square root of 4, I get 2. Okay, so once again, we have a positive perfect square discriminant, right? What's underneath there. And so I'm going to bring down the 2 here. 2 times 3 on the bottom is 6. Okay, so then we end up with 2 plus 2, which is 4 over 6, right? And then 2 minus 2, which is 0 over 6. So we get 2/3, comma 0. That's our final answer. All right. So when c is equal to 0, one of your roots is going to be 0 as well. One of your solutions roots, zeros, is going to be 0 as well. Okay. So when c equals 0, one of your roots or solutions is also going to be 0. And so that means you have, it's going to be good. It's going to cross through the origin. So when c equals 0, it's going to cross through the origin. All right. And so once again, with these two, we had positive perfect square discriminants. And so we ended up with 2 real and rational roots again.